In this problem, we are given two rectangles and we need to figure out whether they overlap or not. One rectangle is like this and other is like this. Okay, we can clearly see that some portion of the first rectangle and second rectangle, they intersect. So this is the common area. We need to figure out whether there is a common area exist or not. Before going further into this problem, I need to share an analogy. In one-dimensional system, say you are going to campus and your friend is also going to the campus. Your friend has arrived on 9 o'clock and you have gone there at 10 o'clock. You need to figure out the total time spent together. In other words, the intersection or the common portion of the time in on campus. So this 9 o'clock is your friend and this 10 o'clock, that is you. In order to in order for a common area to exist, uh, when that when that common portion will start, the starting portion, when it will start, it must, if there is a common area exists, it must start from the later arrival. Actually, whoever arrives late, the later arrival. Before this later arrival, there wasn't two person, there was only one person. So obviously it is a common sense that the later arrival point will be the start of the common portion. Okay, then you spend some time there and you left the campus at 1 p.m. and your friend left the campus at 5 p.m. So what's the common portion? The end time will be the earlier leave or earlier departure. So you left at 1 p.m. and your friend left at 5 p.m. So what is the common or spending time together portion? This is that from 10 a.m. to 1 p.m. So this is the portion. So we can see that if a common area exists, it will start at the later arrival and it will end at the earlier leave. So this makes sense. Uh, it is a case for one dimension, by the way. What if what if it was disjoint, like your friend arrives at 9 o'clock and this is not you, and your friend leaves at 12 p.m. friend leave. Okay, and you arrive at 1 a.m. and you leave, sorry, 1 p.m. and you leave at 5 p.m. So there is like no common area. Right, there is no common area. This is your friend's portion, this is your portion. uh, Whatever we have said, the starting portion will be the later arrival. So you're gonna say that this is the later arrival and whoever leaves early, your friend leaves early. So this is this area. So you can see that this starting portion is later than the leaving portion if you apply the rule. Okay, what was the rule? The starting will be the later arrival and common area ending time will be the earlier leave. So if we apply this formula, we can see that the starting portion is lagging behind the leaving portion. So we can easily say that there is no common area here. Okay, this was the case for one dimension. We will apply this same logic to two dimension in two cases, in x axis and y axis. And if we can understand this, we'll be able to solve 3D problems too. Okay, what will be in the case of rectangle? say there is two rectangles. One is here and another one is here. There are two rectangles, and we are given the coordinate of the top, bottom right, bottom left, and top right portion. Okay, for these two rectangles, you can say you can see that the intersection point of the bottom left corner, the intersection point of the bottom left corner, we can calculate this for x axis and y axis separately. Okay, using the same logic we have seen earlier. What will be the x coordinate of the bottom left point? It will be the, what will be it? Later arrival. Okay. Later arrival. The maximum point between this x and this x. Okay. So whatever is maximum minimum. If we denote, let's say, we can say that this is 2 and 10, bottom left point. This is 5 and 2, bottom left, and this is 20 and 20. This is 15 and 30. Okay, so between these 2 points, this is the x portion of the bottom left, this is the x portion of the bottom left of the second rectangle. So whichever arrives late, or which one is the maximum, so this one. So this intersection point has x coordinate of 5, we can say that, because x has arrived, because this rectangle has arrived late. For the y coordinate, who has arrived late? This rectangle has arrived late, because you can see that this has 10 and this has 2. So the y coordinate of this bottom left intersection point is 10. We have calculated it. Similarly, for this portion, this overlapping portion, the top right portion, this has an x coordinate of 15, because we have seen that earlier leaf. So whichever has the minimum value, that will be our x coordinate. Between 15 and 20, 15 is smaller, so this is the x coordinate, and between 30 and 20, whichever is smaller, 20 is smaller, so this has 20 as y coordinate. So you can see that this is our bottom left corner and this is our top right corner of the overlapping portion, and we can construct a rectangle here. Okay, and we can also calculate its area if you want. So we have found the intersection point. Fine, that's so cool. But what about if the rectangles do not overlap? This one is a rectangle and this one is another rectangle. This top right portion, this is top right portion, bottom left, bottom left. Following the same formula, we are going to calculate the bottom left of the intersection point. What will be the x coordinate between this and this, which is maximum? 17. Which is maximum between 10 and 2? 10. So we have calculated that bottom left coordinate is this. And what about the top right? 15 and 25, whichever is smaller, 15. 20 and 17, whichever is smaller, 17. But we can, there is no overlap, we can visually see it here, but how will computer understand this? Okay, so 17 and 10 and 15 and 17, if we plot it somewhere like 17 and 10, 17 and 10, this is the supposedly intersection bottom left point, and top right point is 15 17, 15 17, this. we are saying that this is the bottom left point and this is the top right point. Okay, so we can see that if these two rectangles does not overlap each other, the bottom left portion will be on the right side of the top right portion and on the lower side, maybe or may not be on the lower side. So this consistency breaks. Okay, this is obvious, like because between this later arrival and earlier leaf there will be an inconsistency which will cause the bottom left portion to be on the wrong side. So if we calculate bottom left, and after calculating bottom left and top right position, we can just check for consistency. If they're consistent, then yeah, they overlap. And if they do not, if they aren't consistent, then we can say that these two rectangles do not overlap each other. So in the code, we are saying that we are taking the first rectangle and second rectangle. They are given as input. Then we have calculated the bottom left x of the overlapping portion and bottom left y of the overlapping portion, top right x and top right y. Then we are checking if top right position of the x is greater than the bottom left position of the x, and top right position of the y is greater than the bottom left position of the y. Okay, this is like this. The bottom left x, this is the bottom left x and this is the top right x. The top right x must be on the right side of the bottom left x. Okay, again the top right y must be bigger than bottom left y in order for the area to be positive. Okay, this is our logic. If this holds, then we can say that these two rectangles overlap each other.